Hello friends, after the ISRO's historically successful launch and the landing of Chandrayaan 3 on lunar South Pole on this August 23, 2023, romancing the lunar surface for 14 days, observing its soil composition. In less than 2 weeks, ISRO has decided for the Surya Namaskar. Yes, on the 2nd of September 2023, Saturday at 11:50 am, ISRO has launched India's maiden solar mission, that is Aditya L1, after several years of development. So far, only the US Space Agency, NASA, and the European Space Agency ESA have independently as well as jointly launched the solar missions, while Germany had only sent its probes through the US NASA mission. Today, India is not eyeing on the moon, but on the sun through this solar mission. In this video, let us try to understand everything about this Aditya L1 mission in detail. As I said, this Aditya L1 is India's first solar mission which is going to study about the sun specifically. But the way Chandrayaan 3 had landed on the moon, Aditya L1 is not going to land on the solar surface. It is going to observe the solar surface from a distance only. In fact, the spacecraft will be more closer to the Earth than the sun during this mission. More specifically, after the launch of Aditya L1, it will be going to cover 1.5 million kilometers, that is around 15 lakh kilometers away from the Earth, which is around 1/100th of the distance between the Earth and the sun. And then it will reach to its destination, which is Lagrange Point L1, and will orbit around this L1 in a halo orbit. And that is the reason the mission is called as Aditya L1 mission. The Aditya L1 will take around 4 months to reach this point L1 and will stay there for the next 5 years. And that is why Aditya L1 is not just a spacecraft, but it is the solar space observatory. Now, the obvious question comes to your mind is, what is this Lagrange point L1 and why Aditya L1 is going to be placed only here in the space? Let me explain this. Lagrange points are those unique positions in space where an object is sent, tends to stay there. Why? Because at Lagrange points, the gravitational pull of the two large masses, that is the celestial bodies, in this case it is the sun and the moon, precisely equals the centripetal force which is required for the object to move with these large masses. These points in space can be used by the spacecraft to reduce the fuel consumption needed to remain in the same position. There are 5 such Lagrange points between the sun and the Earth, named as L1, L2, L3, L4 and L5. Then why only L1 is selected for Aditya mission? Lagrange point L1 is such a unique position from where both the sun and the earth can be observed continuously, which means the sun and the earth will never be hidden behind each other's shadow. Now, going forward, let us talk about what is this Aditya L1 going to study about the sun. To understand this, let us first understand about the sun of our solar system. The size of the sun or its diameter is around 109 times bigger than the earth, and its weight is around 3,33,000 times more than the earth. There are different layers on the sun. The first one is inner core, where the nuclear fusion reactions taking place, where hydrogen and helium gets converted into energy, producing the sunlight and heat. The next one is radiative zone, because of the heat transfer or the energy transfer taking place due to radiation mode. The next one is convective zone, because here the heat transfer or the energy transfer is taking place by the convection mode. Then comes the solar surface, that is photosphere. Even though it is called as solar surface, but it does not have, the sun does not have the surface like the earth or the moon, because it contains the hot gases and plasma. So it can also be called as, the photosphere can also be called as the lowest layer of the solar atmosphere. Then comes the chromosphere, and then the outermost layer of the solar surface or outermost layer of the solar atmosphere called corona, consisting of extremely hot plasma. So its temperature is extremely very high, which is around 1 to 3 million degrees Celsius. The inner layer, photosphere, is comparative, the inner core is very hot, and the photosphere and chromospheres are comparatively colder, but again the corona becomes extremely hot. The mission of this Aditya L1 is to study the three layers of the sun, that is photosphere, chromosphere and corona. So apart from heat and light, the sun also emits the various types of radiations like radio waves, infrared radiations, visible light, which we can see through our naked eyes, ultraviolet rays, which can cause the skin cancer, and other harmful radiations like X-rays and gamma rays. But our Mother Earth protects us from these harmful radiations. Now, Aditya L1 is going to study the solar activities and their effects on the space weather. The scientific objective of this Aditya L1 mission includes the study of coronal heating to understand the reason behind extremely high temperatures of corona layer, that is around 1 to 3 million degrees Celsius. As I said, corona becomes again very hot. People still do not know the reason behind it. Then it is going to study the solar wind acceleration, which is a huge wave of charged electrons and protons. The next objective is to study the coronal mass ejections, CMEs, which are big bursts of solar wind and magnetic fields. And another is to study the dynamics of solar atmosphere and temperature anisotropy. That is the variation of temperature in different directions. To measure these things, the spacecraft is carrying 7 scientific instruments, which are known as 7 payloads. The first one will be visible emission line coronagraph, in short VELC. It is going to study the coronal layer to observe the coronal mass ejections, CMEs. The second payload is Solar Ultraviolet Imaging Telescope, in short SOOT, to take the images of photosphere and chromosphere in the ultraviolet spectrum. The third payload is Solar Low Energy X-ray Spectrometer, in short SOLEX. And the fourth one is High Energy L1 Orbiting X-ray Spectrometer, in short HELIOS. These two, SOLEX and HELIOS, are going to study X-rays emitted by the sun. The next one is Aditya Solar Wind Particle Experiment, in short ASPEX. And the sixth one is Plasma Analyzer Package for Aditya, in short PAPA. These two, ASPEX and PAPA, will be studying the solar winds. And the last one is the magnetometer, in short MAG, which will be going to measure the magnetic field reaching the L1 point. Now you must have understood that it is necessary to get out of the Earth's atmosphere to study the solar activities and their effects on the space weather, because Earth's atmosphere prevents lot of harmful radiations and other things reaching the Earth. So thank you for watching this video.